Hello everyone, welcome back to the Medi. I am Suchitra. So today we are going to explore a very interesting and innovative topic in the novel drug delivery systems, that is Mucoadhesive Drug Delivery System. So before starting, I have a simple question. So have you ever tried to stick a wallpaper to a wet surface? Interesting, right? So sometimes it remains attached because attractive forces develop between the two surfaces here. So now imagine a medicine doing something similar inside our body. So instead of immediately moving away, the dosage form says, "No, I want to stay here for some more time and release my drug slowly." So that is the basic beauty of the mucoadhesive systems. So today we will understand the mucin mechanisms, theories, polymers, routes of administration, dosage forms, advantages, limitations, and much more. So students, keep your notebooks ready and stay with me until the end because we are going to understand the mucoadhesion through very simple examples. So let's begin our journey. Mucoadhesive Drug Delivery System. So look at the title carefully. The word muco refers to the mucus or a mucosal surface here. So the word adhesive means the ability to stick. So therefore the mucoadhesive drug delivery system is designed to stick to the mucosal surface and remain there for a certain period of time. So imagine a normal tablet traveling to the gastrointestinal tract. It may move from one region to the another. So, but mucoadhesive dosage form is designed to remain attached to the particular mucosal region. So, why? Because increased residence time can improve drug release and in suitable cases drug absorption also. So, we can call this a novel approach for the prolonged drug action. Okay. Introduction to the mucoadhesion. So, mucoadhesion is the ability of the material to adhere to the mucus or the mucosal surface. So, students, think about a small sticker. When we place a sticker on a notebook, it remains there because adhesive forces hold it. So, in mucoadhesion, similarly, specially selected polymers helps the dosage form interacts with the mucus here. So, this may prolong the residence time of the formulation. For example, so consider a buccal tablet. So a conventional tablet is normally swallowed, but a mucoadhesive buccal tablet can remain attached to the inner cheek here. So the drug can be released gradually. So mucoadhesive systems can be designed for both local and the systemic drug deliveries. Okay. So let us define the mucoadhesive drug delivery system. So it is a system in which a dosage form adheres to the mucus or the mucosal membrane and remain in intimate contact with it for a prolonged period of time. So the main keywords are adhesion, intimate contact, and prolonged residence. So suppose we want to deliver a drug through the buccal mucosal. So if the dosage form remains only for a few seconds, sufficient drug release may not occur. Okay, but if the formulation adhere properly, the drug gets more time to release at the intended site. So therefore the residence time is an important concept in the mucosal adhesive drug delivery. Okay, so what is mucus? So before studying the mucoadhesion, we must understand the mucus. So mucus is a slippery gel-like secretion. It covers several mucosal surfaces of our body. So you can find mucus in the respiratory tract, gastrointestinal tract, and the reproductive tract. So what is its natural function? Its function is to give the protection and the lubrication. Okay, so think of the mucus as a soft protective blanket covering the delicate tissues. For example, the gastrointestinal mucosa needs protection from the different luminal contents. Okay, So mucus contributes to this protective environment for mucoadhesive formulations. So this mucus layer become an important surface for the interaction here. Okay. So structure of the mucus layer. So observe the mucus layer carefully here. So the outer region is generally looser and less viscous here, and the inner region can be denser and more closely associated with the epithelial surface. So below the mucus layer we have the mucosal epithelial cells. So imagine a layered dessert. So the upper layer may be looser and the lower arranged, while the lower layer is denser. Similarly, so mucus is not simply a uniform layer of water. So its structure and the rheological properties influences the interaction of the mucoadhesive polymer with the mucosal surface here. Okay. Now we meet the star molecule of our topic, that is mucin. So mucin is a major glycoprotein component of the mucus. The word glycoprotein tells us that it contains the protein associated with the carbohydrate groups. So mucin molecules contribute significantly to the gel-like nature of the mucus here. So imagine mucin molecules as long molecular chain forming an intangible network here. So mucoadhesive polymers can interact with this mucin network. So these interactions are central to the mucoadhesion. So remember, mucus is the secretion, while mucin is an important glycoprotein component within mucus. Okay. Concept of mucoadhesion. So mucoadhesion is the attachment of the dosage form to a mucosal surface through an interfacial forces. So the word interface means the region where the two surfaces meet. So here one surface is the mucoadhesive formulation and the other is the mucus or the mucosal surface. So when the two come into close contact, so various interactions may develop. Students, imagine shaking hands. So if two people stand far apart, they cannot shake hands. First they must come close, right? Similarly, the polymers and the mucus must establish the close contact before significant adhesive interactions develop. So the basic principle is very simple. So mucoadhesive polymers interact with the mucus layer and resist rapid removal. So normally biological clearance mechanism may remove a formulation from a site. Saliva, mucus, turnover and the physiological movements can reduce the residence time here. So mucoadhesive polymers attempt to assist these challenges. So think about a boat in a flowing water. So without an anchor, the boat moves with the current. So with an anchor, it can remain in the location for a longer time. So the mucoadhesive polymer acts conceptually like an anchor for the dosage form here. Mechanism of the mucoadhesion. So now observe the complete sequence. Contact, wetting and swelling, adhesion, drug release and absorption. Okay, so this is a beautiful stepwise process. First, the formulation approaches to the mucosal surface. Next, the hydrophilic polymer may interact with the water and swells, and polymer and the mucin chains can come into the closer interaction. Okay, later the adhesion bonds or attractive forces develop. Finally, while the dosage form remain at the site. So remember this sequence because it makes the entire topic easier. Okay. The first stage is the contact stage. So the dosage form come into the contact with the mucus layer. So close contact is essential here. So imagine trying to glue two pieces of paper without bringing them together is impossible, no? Similarly, so the mucoadhesive polymer must establish the contact with the mucus here. So the dosage form may be placed directly at the site, as in the buccal, or rectal delivery. So the initial contact allows the next stage of the mucoadhesion to begin. Okay. So after contact consolidation, so here the adhesive interaction becomes stronger. So the polymer hydrates by absorbing the water from the mucous environment. It may swells also. So the polymer chains become more mobile here. So this can increase the interaction with the mucin chains. So imagine dry noodles and the cocoon noodles. So dry noodles are rigid. So after absorbing water, they become flexible, right? Similarly, the polymer hydration can increase the chain mobility and facilitates the interaction with the mucin network here. Wetting and swelling. So hydrophilic polymers love water. So the term hydrophilic means having an affinity for the water. So when such a polymer contacts the mucus, it can absorb the water and swells. So a gel layer may form. So think about a dry sponge placed in a water. So initially it is very small and dry. So after absorbing water, it becomes larger and softer. So swelling can increase surface contact. So however, the students excessive hydration may sometimes weaken adhesion also. So an optimal level of hydration is highly important here. Okay. Interpenetration. So now polymer chains and the mucin chains may interpenetrate. So what does interpenetration means? So it means the chains enters and intact within the each other molecule network. So imagine the two combs. So when the teeth of the two combs enter between each other, they become interlocked. Similarly, the flexible polymer chains and the mucin chains can become intangible here. So the depth and the extent of the chain penetration can influence the adhesive strength. Okay. So after close interaction, so different adhesive forces can help hold the polymer and the mucin together here. So these may include the hydrogen bonding, van der Waals force, and the electrostatic interactions. So hydrogen bonding is especially important for the polymers containing the suitable functional groups. So think of these interactions as many tiny hands holding the polymer and mucus together. So one tiny interaction may appear weak, but thousands of the molecular interactions acting together can produce the meaningful adhesion here. Okay. So drug release. So once the dosage form is attached, so the drug release begins or continuous. So the drug is released from the dosage form while the formulation remains associated with the mucosal surface here. So imagine a water tank releasing the water slowly through a small outlet. Similarly, the adhesive dosage form may be designed for controlled or the prolonged drug release here. So the release rate depends on the formulation factors such as the polymers, dosage, form design, and the drug characteristics. So drug absorption. So after release, the drug may diffuse through the mucus and reach the mucosal membrane. So depending on the drug and the route, absorption may occur across the mucus here. So let us use a simple example. So imagine students living in a classroom. So first they came out of their seats. So that is like the drug release. Then they move through the corridor. So that is like diffusion. So finally they cross the school gate. So this is compared to crossing in a biological membrane. So release and the absorption are related. So but they are not exactly the same process here. Okay. Theories of mucoadhesion. Scientists have proposed several theories to explain this mucoadhesion. So why several theories? Because mucoadhesion is a complex phenomenon. So one theory alone cannot explain every interaction. So the important theories includes wetting theory, diffusion theory, electronic theory, adsorption theory, mechanical theory, and the fracture theory. So do not simply memorize the names here. So understand the basic idea behind the every theory. Okay. So first theory is the wetting theory. So wetting theory focuses on the ability of the formulation to spread over the mucosal surface. So think about a drop of water on a glass. Sometimes the drop spreads. Sometimes it remains as a rounded droplet. So better spreading means better surface contact here. So similarly, if a mucoadhesive formulation wets the mucosal surface effectively, so a larger contact area may be established here. So greater intimate contact can support the adhesion. So the keywords for the wetting theory is the spreadability and the surface contact, right? Diffusion theory. So diffusion theory explains the mucoadhesion through the interpenetration of the polymer and the mucin chains. So imagine two plates of cooked noodles placed together. So the flexible noodles from one plate can become mixed with the noodles from the other. Similarly, the polymer chains can diffuse into the mucin network, and mucin chains may interact with the polymer network. So chain flexibility and the contact time influences this process. So the keyword is interpenetration and entangibility of the chains. Okay. Electronic theory. So the electronic theory involves the electron transfer between the two contacting surfaces. So this may leads to the formation of an electrical double layer. So attractive electrostatic forces can then develop. So think about the static electricity. Sometimes a small pieces of paper is attracted to a charged object. So in mucoadhesion, the concept is more molecular and complex. But the simple idea is a electrical attraction between the interacting surfaces here. The keyword is the electrostatic attraction. And next is the adsorption theory. So adsorption theory says that after initial contact, so secondary chemical interactions can develop between the adhesive polymer and the mucin here. So hydrogen bonding and the van der Waals force are examples here. So imagine Velcro. So one hook alone may not hold strongly, but many small contact points together produce attachment here. So in a similar conceptual way, the numerous secondary interactions contributes to the mucoadhesion here. So the keyword is the secondary bonding forces. Mechanical theory. So mechanical theory focuses on the surface irregularities. So the polymer may enters the small irregularities or microscopic spaces present on the mucosal surfaces. So this produces the mechanical interlocking. So imagine cement entering a small cracks in a wall. So after setting, it becomes mechanically anchored. Similarly, penetration of an adhesive material into the surface irregularities may contribute to the attachments. So the keyword is the mechanical interlocking. Fracture theory. So fracture theory look at the force required to separate the two adhesive surfaces. So students, imagine sticking two pieces of a tape together. So now try to pull them out. So the force required for separation gives information about the strength of the adhesion here. So the fracture theory is particularly useful when evaluating the adhesive strength. So the keyword here is the separation force. Site for the mucoadhesive drug delivery. Where can mucoadhesive drug delivery systems be used? So several mucosal sites are available. So they include the buccal, sublingual, nasal, ocular, gastrointestinal, rectal, and even vaginal sites. So each site has unique advantages and limitations. For example, the buccal route uses the inner cheek. The sublingual route uses the area around the tongue. The nasal route involves the nasal mucosa. So the selection of our route depends on the drug therapeutic objectives and the formulation design. First one is the buccal route. So the buccal delivery mainly depending on the drug through the inner cheek. So a mucoadhesive dosage form can be placed against the buccal mucosa. So imagine placing in a small tablet inside the cheek. So the tablet adheres to the mucosal surface and releases the drug here. So the buccal delivery is very attractive because the site is relatively accessible here. So the dosage form can be removed if necessary. So the mucoadhesive tablets and the films are commonly studied for that buccal delivery here and sublingual delivery. So sublingual means under the tongue. So the mucosal region under the tongue, that is, it has a rich supply of the blood here. So this route is commonly associated with the rapid drug absorption for the suitable drugs. So now remember an important distinction here. So the buccal means cheek, sublingual means under the tongue. So students often confuse these two. So a simple memory trick is B for buccal and B for side of the mouth. So S for sublingual and S for space under the tongue. Nasal delivery. So in a nasal mucoadhesive delivery, a formulation interacts with the nasal mucosa. So one major challenge in the nasal cavity is the mucociliary clearances. So the natural clearance system can remove the foreign materials. So a mucoadhesive polymer may increases the residence time of a formulation here. So imagine an excavator continuously moving the materials away. So the mucoadhesive attempt to keep the formulation at the site for longer here. Nasal gels and other mucoadhesive formulations have been widely investigated. Ocular delivery. So the eye presents a major drug delivery challenge. Why? So because tears and the blinking can rapidly remove the conventional formulations. So have you ever used eye drops? So sometimes the lipid immediately flows out of the eye. So this means the contact time can be short. Okay, so mucoadhesive ocular systems aim is to improve the contact with the ocular surface. So however, ocular formulations must be carefully designed to avoid the irritations and maintain the patient comfort. Okay, and gastrointestinal delivery. So gastrointestinal mucosal adhesive systems are designed to interact with the GI mucosa here. The aim may be to increase the residence at a particular region and support localized or the prolonged drug delivery systems here. So imagine a train passing through many stations, a conventional dosage from continuous traveling. So a mucoadhesive formulations attempts to stay longer at a selected station. So however, the gastrointestinal environment is highly dynamic. So the mucus turnover, food and motility can affect the adhesion sometimes. Mucoadhesive polymers. So now we enter the heart of our formulation science, that is polymers. So mucoadhesive polymers are the materials capable of interacting with the mucus and prolonging the residence time of a dosage form. So students, the polymer is like the main actor in a movie. So without a suitable polymer, effective mucoadhesion may not occur. So for example, includes the carbapoles, HPMC, chitosan, sodium alginate and the sodium CMC. So polymer selection influences the swelling, viscosity, drug release and adhesion. So ideal properties of the polymers. So what should an ideal mucoadhesive polymer possess? So it should be non-toxic and non-irritant. It should demonstrate the suitable mucoadhesion. It should be biocompatible. So hydrophilicity and the swelling ability are often useful here. So it should also support the controlled drug release when required. So imagine selecting a good employee. So you don't select a person based on only one quality. Similarly, a polymer is not selected only because it is sticky. So safety, compatibility, stability and the formulation performances are also important here. Natural polymers. So natural polymers are obtained from the natural sources. For example, includes chitosan, sodium alginate, gar gum, xanthan gum and pectin. So students may ask, Madam, does the natural always mean perfect? I say no. So naturally polymers can offer useful properties, but batch variability, microbial considerations and processing characteristics may need attention here. So each polymer must be evaluated scientifically. So chitosan is particularly interesting because of its cationic nature. Synthetic polymers. Synthetic and the semi-synthetic polymers are also used. Example includes carbapoles, HPMC, sodium CMC, polycarbophyll and PVP. So these polymers can provide the useful and the reproducible formulation characteristics here. For example, HPMC is widely used in the pharmaceutical formulations because of its hydration and the gel forming properties. So carbapole is known for the strong mucoadhesive characteristics. The selection depends on the formulation objectives here. Okay. And next is the carbapole. So carbapole is an important mucoadhesive polymer. It mainly contains the carboxy groups. So these functional groups contributes to the hydration and interaction such as hydrogen bonding. So whenever there is a hydrogen groups or carboxyl groups, there may be high chances of this hydration bonding. Okay, so imagine a polymer chain containing many possible interaction points. So more suitable interaction sites can support the polymer mucin interaction here. So carbapoles can also swell significantly in an aqueous environment. So however, the concentration and the formulation conditions must be optimized. Okay, and next is the HPMC, that is hydroxypropyl methyl cellulose. So it is a hydrophilic polymer. So when exposed to the water, it hydrates and can form the gel layer. So students, imagine a dry tablet containing HPMC. So when water reaches the tablet, the polymer start hydrating here. So a gel-like barrier develops. So this gel layer can influence the drug diffusion and the release here. So because of these properties, HPMC is widely used in the control release and the mucoadhesive formulations. Okay. Chitosan. So chitosan is a very interesting and the natural polymer. So it is a cationic one. So that means it can carry the positive charge under suitable conditions. So mucin can contains the negatively charged groups. So therefore the electrostatic interactions may occur between the chitosan and the mucin here. So think about the opposite poles of the magnet attracting each other. So this is only a simple analogy, but it is helps us understanding the interaction and the attraction here. So chitosan is extensively investigated in the mucoadhesive drug delivery. Sodium alginate and the sodium CMC. So sodium alginate is a natural polymer while sodium CMC is a cellulose derivative. So both are hydrophilic polymers. So used in the pharmaceutical formulations, they can absorb the water, increase the viscosity and contributes the mucoadhesion here. So imagine preparing a thin watery solution. So now add a suitable hydrophilic polymer. So the system may becomes more viscous here. So polymer chains can interact with the aqueous environment and the mucosal surface here. So these properties make them useful in the various mucoadhesive dosage forms. Okay. First generation polymers. So first generation mucoadhesive polymers generally interact through non-specific mechanisms. So these includes the natural and the conventional hydrophilic polymers. So they may demonstrate the good hydration and the adhesion here. So however, their interactions are very less site specific. So imagine an ordinary glue. So it can stick to many surfaces but does not specifically recognize one particular surface. So this analogy helps us understand the first generation polymers here. So their mucoadhesion is generally based on the conventional physiochemical interactions. Second generation polymers. So second generation polymers, the mucoadhesive systems aim for more specific interactions and improved performance here. So they may include the advanced polymers designed for stronger or more selective mucosal interactions. So imagine a normal key compared with a specially designed key. So a normal adhesive may interact non-specifically, but a targeted bioadhesive system may be developed for more selective interactions. So this area is very important in the advanced drug delivery research. Mucoadhesive dosage forms. So mucoadhesive systems can be prepared in different dosage forms like tablets, films or patches, gels, microspheres. So why do we need different dosage forms? So because one design cannot satisfy every therapeutic requirement. For the check, a film may be convenient. For a mucosal cavity, a gel may spread effectively. For particular delivery, the microspheres may be considered here. So the dosage form selection is therefore site specific and the purpose specific. Okay. So mucoadhesive buccal tablets are mainly designed to adhere to the buccal mucosa here. So after placement, the polymer hydrates and the tablet interacts with the mucosa surface. So the drug release then occur gradually here. So imagine a small drug depot attached inside the cheek. So instead of swallowing the entire dosage form immediately, the system remains at the site here. So the tablet must be suitable size, shape and adhesive strength to support the patient comfort. Mucoadhesive films and the patches. So films and patches are the thin and the flexible dosage forms. So they can be designed to adhere to the mucosal surface. So one important advantage is their relatively low thickness here. So imagine a very thin postage stamp. So a mucoadhesive films may be conceptually resembles a flexible sheet carrying a drug and a polymer. So some systems can also be designed for directional drug release here. So the film must remain flexible, non-irritating and comfortable. Mucoadhesive gels. So mucoadhesive gels can spread over a mucosal surface. So because of their semi-solid nature, they may provide the drug surface coverage here. So imagine applying a gel to a surface. So it spreads and establishes a close contact. If the formulation contains a suitable mucoadhesive polymer, so the residence time may be improved here. So gels are investigated for the nasal, ocular, vaginal and other mucosal applications. So the viscosity is very important here. So too thin and the gel may dry rapidly. So if it is too thick means the administration may become difficult. So formulation is always about balance. So mucoadhesive microspheres. So microspheres are the small spherical particles. So the mucoadhesive microspheres are designed to interact with the mucosal surface. So students, so imagine the hundreds of the tiny drug carrying balls. So instead of one large dosage form, many small particles are distributed over the mucosal surface. So this can increase the contact area. So drug can be incorporated within or associated within the microsphere here. So particle size, polymer characteristics and the drug behaviors are very important formulation parameters here. Factors affecting the mucoadhesion. So several factors affects the mucoadhesion here. So the polymer properties are important. Polymer concentration matters here and the molecular weight can influence the chain interactions and the degree of the cross-linking effects change the mobility and the swelling here. So the contact time is important. So the environmental pH, ionic strength can also influence the polymer behavior here. And imagine the preparing a tea. So the final taste depends on the water, tea powder, milk, sugar and the boiling time, right? So changing one factor can change the result. So similarly, the mucoadhesion is controlled by multiple interacting factors here. So now let us discuss the advantages. So mucoadhesive polymers may prolong the residence time. They can improve the drug contact with the absorption site. They can support the controlled drug release. In suitable systems, dosing frequency may be reduced. So better residence and the conventional delivery may improve the patient compliance here. So but students, remember one important scientific point. So mucoadhesion does not automatically guarantee improve the bioavailability of every drug. So the drug membrane permeability and the formulation design must all be suitable. Okay, so every drug delivery system has limitations. So mucus turnover can remove the formulation sometimes, and the saliva can dilute the buccal formulations, and eating and drinking may disturb the dosage form in the oral cavity. So some polymers may be cause irritation. So drug loading may be limited in small films or tablets. So think about our anchor example. So even a boat with an anchor can move if the water current becomes extremely strong. Okay, similarly the physiological clearance mechanisms can reduce the mucoadhesive residence time here. So therefore formulation optimization is essential. Okay, students, it is revision time. So what is the mucoadhesion? So attachment of the material or the dosage form to the mucus or the surface, its surface, mucosal surface. So what is mucin? An important glycoprotein component of the mucus. So what are the major stages? So contact and the consolidation are the two main stages here. So what happens during the consolidation? Hydration, swelling, chain interaction, and the strengthening of the adhesion. Okay, so name important theories. So wetting, diffusion, electronic adsorption, mechanical, and the fracture theories. So name some mucoadhesive polymers: carbapol, HPMC, chitosan, sodium alginate, and sodium CMC. So name the dosage forms: tablets, films, patches, gels, and microspheres. Excellent, no? So the major objective of the mucoadhesive drug delivery is to establish the prolonged contact between the formulation and the mucosal surface. So this can suppose the prolonged residence, controlled drug release, and improve the therapeutic performances in appropriately designed systems. So mucoadhesion is therefore an exciting bridge between the polymer science, pharmaceutics, and the biological surfaces. So students, we have successfully completed our journey through the Mucoadhesive Drug Delivery System. So we started with a simple question: can a medicine stick to a biological surface? And now you know the complete scientific answer. So we understood mucus. We met the important glycoprotein mucin. So we explored the contact, swelling, interpenetration, and adhesive bonding. So we compared different theories. So we traveled through the buccal, sublingual, nasal, ocular, gastrointestinal, rectal, and the vaginal drug delivery. So and finally we explored the important polymers and the dosage forms here. So remember one simple line, that is: come close, hydrate, interact, adhere, and release the drug. Finished. So this is the story of mucoadhesion. So if this presentation helped you understand the topic, so please like this video and share it with your pharmacy friends and students. So if you have any doubts, write your questions in the comment section. And most importantly, please subscribe to the Medi Queries and turn on the notification bell. Your support motivates me to create more simple, creative, and the detailed pharmacy educational videos. So thank you so much for watching. Keep learning, keep exploring pharmacy, and I will meet you in the next interesting topic. This is Suchitra from Medi Queries. So thank you and happy learning.